In this video, we're going to take a look at how you factor the algebraic expression ax squared plus bx plus c, so the general quadratic trinomial. And this video covers when the quadratic term here has a coefficient that generally isn't 1. Now this method still works if a was 1, but this is normally what's used, or one of the normal methods that's used, when the x squared, or whatever the variable is, coefficient is not 1. And there's an instruction here, we'll get into that in a moment. This example is meant to illustrate why we need to do what's over here in words. And so factoring and expanding are opposite operations. So in this example, we're going to expand 3x plus 1 by 2x plus 5 to get this. And so, and then the idea is, well, how do we actually then go backwards if we have this, get the two factors? So if we multiply 3x plus 1 by 2x plus 5, you multiply, and if you're used to using FOIL, this line really is FOIL, or the beginning of FOIL. We multiply the 3x by each term over here. Normally people write 3x times 2x and then 3x times the 5, and that's really what that means. 3x gets multiplied by each of these two terms, and then plus the 1 gets multiplied by each of these terms, and that's what that second line says there. So when we actually do the multiplication, 3x times 2x is 6x squared, 3x times 5 is 15x, 1 times 2x is 2x, and 1 times 5 is 5. And so there are two like terms in the middle here, the 15x and 2x, to add to 17x. So it simplifies to 6x squared plus 17x plus 5. So that's an example of expanding. Now we want to be able to go from here back to the two factors. And you're really just reversing the steps here. And so if you're going backwards, you're actually breaking the 17x down into two terms that still add to 17x, 15x and 2x in this case. And then you actually could, from this line to this line, do a little bit of common factoring and then factor by grouping. And really the whole thing is called factoring by grouping. So you can factor a 3x out of these two terms, and if you factor 3x out of 6x squared, you get 2x. 3x out of the 15x gives you 5. And then there's actually no common factor or a common factor of 1 in these two terms. You factor a 1 out. And then you could actually go from this line to this line by, well, it's really factoring by grouping. Factor the 2x plus 5 out of these. So that's the 2x plus 5 factor. And the other factor is 3x plus 1. Now the idea is, though, how do you know what to break the 17x down into? Why is it 15x and 2x? Why couldn't it be, 4x and 13x? Well, you see, we want to break it down into the two terms so that this factoring by grouping works. And notice that if you start with this here, obviously the 15 and 2 add to 17. But if you take the product of 6 and 5, that's 30. And 15 and 2 add to 17, but they also multiply to 30. See, 15 times 2 is 30, just like 5 times 6 is 30. So to know which two numbers to use here to break that middle term down into, the two numbers add to 17, but also multiply to the product of these two numbers. And so that's what this instruction is saying over here. To factor ax squared plus bx plus c, you look for two numbers, like the 15 and 2, that add to the b, which is the 17 in that case, and then also have a product of the a times c, which is the 6 and 5, or the a and c here. And you use these two numbers to break the bx term into, and then factor by grouping. And so we're going to take a look at a couple of examples of using this to factor, and then in the next page we'll get into another method. And so we're going to factor 4x squared plus 5x minus 6. And so we'd look for two numbers that add to or have a sum of 5, and then multiply to 4 times negative 6 is negative 24. And so they have a sum of 5 and a product of negative 24. Now, in this case, I'm going to write out all the numbers that have a product of negative 24. And then we'll choose from that list the ones that also have a sum of 5. So here's all the numbers. So the numbers that multiply to negative 24 could be 1 and negative 24, or negative 1 and 24. 2 and negative 12, or negative 2 and 12. Notice that if the product is negative, then one of the numbers is negative and one's positive. 3 and negative 8, or negative 3 and 8. 4 and negative 6, or negative 4 and 6. So those are all the 8 pairs of numbers that multiply to negative 24. Now we want to select from there the pair that also has a sum of 5. So the ones that have a sum of 5 would be the negative 3 and 8. That's the only pair of all 8 of these that has a sum of positive 5. And so what we're going to use the negative 3 and 8 for is to rewrite this with breaking the 5x down to 8x minus 3x. So there's the 8 and negative 3. Now, it really doesn't matter which one you write first. You could write 8x minus 3x, or if you wanted to, you could write negative 3x first and the 8x second. It really wouldn't matter. It works out to the same factoring anyway. So now we're going to factor factor by grouping. We're going to group the first two in common factor, the second two in common factor. So in the first ones, there's a common factor of 4x. And we'll start with that. So 4x factors out, and we will get, I'll get into the second part in a moment. So if we divide that by 4x, we get x, and 8x divided by 4x is 2. Remember, when we're factoring a 4x out, to find out what goes in here, you just divide both of those by the 4x. Now you can factor a negative 3 out of these. If that sign is negative, then make sure you factor a negative out. Not just a positive 3. If you factor a positive 3 out, you'd actually have negative x minus 2 here, but you want these two brackets to be the same. So you factor a negative 3 out, and negative 3 goes into negative 3x x times, and negative 6 divided by negative 3 is positive 2. Now these two factors are the same, so we can factor an x plus 2 out, and then the other factor would be 4x minus 3. And so that is factored. Next one, example 2, we're asked to factor 2x squared minus x plus 5. So the numbers we're looking for have a sum of negative 1 and a product of 10. 2 times 5 is 10. And so I'm going to list all those numbers again. There actually aren't that many pairs of numbers that have a product of 10, integers anyway. And so it would either be 2 and 5, negative 2 and negative 5, 1 and 10, or negative 1 and negative 10. That's all the possible pairs of numbers that multiply to 10. And notice that there are no pairs of numbers here that sum to negative 1 or add to negative 1. That adds to 7, that adds to negative 7, 11, and negative 11. So there are none that also add to negative 1, and so we would say that this does not factor. A lot of times in factoring questions, it'll say factor something in comma if possible. Well, this one's not possible, so it does not factor, and that's all you'd have to say. Example number 3, we're going to factor the 6x squared plus 7x minus 5. And so we would look for two numbers that have a sum of 7 and a product of negative 30. And so the negative 30, of course, comes from 6 times negative 5. Now the numbers would be 10 and negative 3. I didn't bother to list all the pairs of numbers that multiply to negative 30 here, but the numbers would be 10 and negative 3 that add to 7 and multiply to negative 30. So what we use those for is to break that 7x term down into two terms, a 10x and a negative 3x. So there's the 10x minus 3x. Remember, the 6x squared stays the same, the negative 5 in the end stays the same. We're just decomposing. A lot of people call this decomposition. We're breaking down the 7x or decomposing into 10x minus 3x. And now we can common factor. There's a common factor of 2x we can factor out of here. And we get a 3x plus 5. So divide this by 2x, you get 3x. 10x divided by 2x would be a 5. Now the only factor here is negative 1. You don't normally write the 1 here, although it's not wrong. You could write negative 1, and then when you factor a negative 1 out, these signs just change. So negative 3x becomes 3x because you're actually dividing negative 3x by negative 1 to give you a positive 3x. And you're dividing negative 5 by negative 1 to give you plus 5 here. And so now we can factor the 3x plus 5 out. And the other factor would be 2x minus a 1. And so that is 6x squared plus 7x minus 5 factored. Now I'm going to show you a different method here called the Australian method. We're actually going to factor the same thing, but I'm going to show you how this different method works. And you still need the 10 and negative 3. You still need two numbers that add to 7 and multiply to negative 30. What you start with, though, is you write two brackets, the size you would usually write a binomial in. And now this is 6x squared. So drop the square, because x times x actually gives you x squared, and write 6x times 6x, 6x at the beginning of each, and then over 6. So whatever that a value is, that times x, same thing, and then the 6 in the bottom. And actually, notice if you actually were to expand this out, 6x times 6x and divided by 6, it would actually give you 6x squared. Now what you do with the 10 and negative 3 is you put them in here. The two numbers that add to 7 and multiply negative 30, the 10 and negative 3. So, and it doesn't matter which one has which. And now what I'm going to do is I'm going to common factor out of this binomial and common factor out of this binomial, whatever I can common factor out. So notice that 2 divides into both of these, okay, and 3 divides into both of these. So if we factor a 2 out of the first one and a 3 out of the second one, if we factor a 2 out of here, there's the 2. Dividing this by 2, we get 3x. Dividing this by 2, we get 5. And then we can factor a 3 out of here. So 6x divided by 3x is 2x minus 1. And we factor a 3 out of a negative 3, and we get a minus 1. And so notice that that 2 and that 3 that we factored out multiplied to 6. This is all multiplied here, actually. 2 times 3 is 6. So that 2 and 3 actually divides out with the 6. And so after you divide that out, notice that the two factors you have are the same from up here, because we factored the same thing. So it factors to 3x plus 5 times 2x minus 1. And so that's the Australian method. Just a different way to factor trinomials than the decomposition method, but it works equally as well. And that's the end of the video.